So we don't have many questions. Maybe the audience will give us some more, but we can start probably with, aside from the runtime directives that we can use to influence the just-in-time compiler, at least in C, is there anything that developers can consider at coding time, not at runtime? Something that they can do to influence this just-in-time compiler, something that they might need to avoid, or?
So to some extent, you have annotations also. You can use those force annotations, and most of compilers respect annotations. So there's a set of those. I cannot remember the exact location where you can read them up, but those are the things that also kind of help a compiler to build proper, to compile code. But for most part, I think I covered what exists today. But it seems like that the general direction in which people are going is to build more friendly interfaces towards feeding those directives. The difficult part is directives are a two-edged sword. They can help you, but they can hurt you as well if they are misused. Because once you give a directive, the compiler must obey to the directive it's provided. So the directives need to be provided with also proper documentation and teaching how to use those. And I just scratched the surface of the JIT compiler. The whole thing is fairly complex. And that's why for most part, vendors, including us, but Oracle and all the others as well, they try their best to produce optimal code without user needing to influence it with directives. It's only die-hard performance people like, I don't know, like Martin that would do this kind of things.
Okay, another question about these directives. You figured out a new kind of optimization. You implemented on your JVM. How do you decide that you want this optimization to be enabled by default? I mean, is it something that happens overnight? I mean, do you just implement it and go sit
Okay,
there,
so this is our internal process, but there's no secret to it. We have a set of workloads that we've obtained by various means. And we have a cluster that does performance testing. So when we implement a new feature, we run through the cluster and see which benchmarks improved, which ones regressed. And based on that, we figure out either we enable it always by default, or maybe there is some more sophisticated logic, like we can detect, okay, so this application is probably using this pattern, so we're going to enable this optimization, otherwise we'll leave it out. Therefore, I'm always on a hunt for new benchmarks. If I see one that's available and the license allows us to use and take it, I'm always looking for new benchmarks, and if any framework makers, any library makers, if they have a performance benchmark, I want to take it. I want to make sure that in the next release we don't regress it. That's how we do it internally. And I think that other VM vendors do mostly the same, except for, well, Oracle is a much bigger organization, for example. So they, beyond user benchmarks, they can also run things on their Oracle cloud, because for them it's also a priority to make sure that their cluster of applications, their vertical stack, does not regress with a new release. We don't have with that because we're just a VM company. We're not like a whole stack company. So we primarily focus on user workloads.
I see. Do you have any experience with some optimization that it passed on all of your benchmarks as an improvement, and suddenly some user for some specific use case figured out that it dramatically affects them, and they had to disable this? And how do you react to this kind of situation?
So good question. I'm trying to recall a specific case, and I cannot remember off the top of my head. But this is what we would typically do. The first thing we do is, if there's something we enable by default, and, well, okay, so the rule of thumb is like, if we enable a new optimization, we always introduce some sort of a switch. Maybe it isn't advertised, maybe it isn't known, but at least our support engineers know. And we tell the customer, okay, go switch flip that switch, disable that optimization. It also helps a lot with testing, and it helps to narrow down a problem, because when you see some sort of a crash, it's quite hard to understand what exactly went wrong. So when you have a lot of switches, which we we happen to have and we expose them to outside, anybody can use them, it becomes much easier to narrow down, okay, so this crash or this malfunction or this performance problem happened because of this optimization. And we'll look at it a bit closer. So typically we do have a set of switches in production that we can ask them to turn off. And while they are off with it and the problem is sort of elevated, we go and study, we try to collect some more data and rework it. It's an iterative process.
Fair enough. Does anybody else have any other question for Ivan?
Okay. I'll be around tomorrow as well. Find me if you would like to ask any other questions. This is my Twitter tag as well. DM me if you have more questions about anything that we do. And thank you very much for coming.
Thank you.